In our second example, we have three consecutive terms, k minus 1, 2k, and 21 minus k, and they are consecutive terms in a geometric sequence. This is key. So we want to find what k is. So if it is a geometric sequence, then we know that the following is true, that I have a common ratio. If I take 2k and divide that by k minus 1, that should equal 21 minus k over 2k. And kind of what I did there is I said, well, if I divide this over this, that should be the same thing as this over this. That's my common ratio. So this is one method of performing this. I'll show you another method that we could do as well. But first off, let's start off by cross multiplying. I can take the product of these two things, so I'll have a 4k squared equals k minus 1 times 21 minus k. And I can expand this a little bit further, and so I'll get 4k squared equals, I'll kind of multiply these two things together, and that will give me a 21k minus 21 minus k squared plus k. And then I can simplify some stuff a little bit, combine some like terms. Let's get everything over to one side. This is a quadratic, so we're going to set it equal to 0. And once I do a little bit of algebraic manipulation here, I'll get 5k squared minus 22k plus 21 equals 0. This does factor, so I'll factor this equation to give me 5k minus 7 and k minus 3. That's equal to 0, and you could check that for yourself to make sure that works. And once we have this, we can separate both factors, solve each, and I'll get k equals 7/5 and k equals 3. So I've got two possible values for k, and it's always important to make sure that they both work. So let's check both of these things. So I'll do my check over here. So let's check k equals 7/5 first. So that means that if I have, let's see, I can check this by plugging in k into my initial sequence, and then we'll see if it's geometric. So I've got 7/5 minus 1, I've got 2 times 7/5, and I've got 21 minus 7/5. All I've done is I've plugged k into my initial sequence. So this is going to be equal to 2/5, comma, that'll be 14/5, comma, and then 21 minus 7/5 comes out to be 98/5. And I'm looking for a common ratio. If it has a common ratio, this is geometric, and it looks like I am multiplying everything by 7, so this does have a common ratio. This checks out. K equals 7 does work. Let's do another check now for k equals 3. So this will be k equals 3. So that means that I'll have terms of 3 minus 1, 2 times 3, and 21 minus 3, or simplifying that out to be 2, 6, and then 18. Again, looking for a common ratio. I do see another common ratio. I see times 3 times 3. So this is a valid k value. So I've got two solutions here. K could equal 7/5, or k can equal 3. Why don't you try this example? Same type of a problem. Set up your common ratios, solve for k, and make sure you check your answers. And this one here, k turns out to only be equal to 2.